All right, so welcome to Unit 5, Lesson 3, video number 2. Like I said, the first video was pretty long, but I will promise you that this video number 2 will be a lot shorter, okay? So for example 2, we have a word problem. I would like you to pause the video and take time to read this on your own and come back to the video. Okay, so now I'll read this problem one more time. It says, you buy 8 hostas and 15 daylilies for $193. Your friend buys 3 hostas and 12 daylilies for $117. Write and solve a system of linear equations to find the cost of each daylily. So, we're writing the equation for this scenario. And of course, I will help you write and set up the equations. And as you can see, there's a guide given to you, and we're going to use this guide. It will tell us how to set up the equation. Okay, so we're going to use this guide for first me and then for my friend. But before we do that, let's go back to our problem and let's see what some information we have. So you have 8 hostas and 15 daylilies, and that's $193. So we know how many hostas and how many daylilies you're buying, but we don't know the cost of each flower. Then your friend is buying 3 hostas and 12 daylilies for $117. And again, we don't know how much they each cost. What are we trying to find? We're trying to find the cost of each daylily. So these are 2 types of daylilies, I'm guessing, and we're trying to find the cost of them. So that's going to be our variable, because that's what we're trying to find. We're trying to find X, let's say that's the cost of hosta. That will be our X, because that's what we're trying to find. We're also trying to find the cost of daylilies, which I'm going to write in a different color. Cost of daylily, and let's say that is our Y. And if you look at the template, that's what they have too. And the reason why cost of hosta and cost of daylily are in X and Y is that those are what we're trying to find. And whatever you're trying to find are the variables. So let's start with U. What is your equation? And it's in orange. It says 8 hostas and 15 daylilies for $193. Well, the total cost is $193, and that's always the constant C. So whatever equation is, it's always going to be equal to 193. Now, the cost of each hosta is X plus, and the cost of each daylily is Y. The number of hosta is 8, and the number of daylilies that you bought is 15. So your equation is 8x plus 15y is equal to 193. And then we have your friend, and this time I'm going to use this different color. Again, we have X and Y. And for this, for your friend, he or she bought 3 hostas and 12 daylilies for $117. So 117 will be the constant for this equation. That's the total. And 3 hostas, and X is hostas, so 3X. And how many daylilies? 12 daylilies. So our second equation is 3x plus 12y equals 117. So we used our story and we used this guide to write our system. Now I'll keep this and I'll continue on with this problem on the next page. Okay, so continuing on the problem, and I rewrote the equation on this slide. Your equation and your friend's equation. Now we're going to solve the system to figure out the cost of our hosta and cost of daylily. And I'll rewrite it here as well. And since this lesson is on elimination method, we will use the elimination. Now let's remember our first step in elimination method. And again, you may refer back to your notes. First is to align terms. You need to align them. And as you can see, it's already aligned. X's are lined up together. Y's are lined up together. Constants are lined up together. Perfect. Step 1 is done. Step 2 is to make the equation have the same opposite coefficients. And if you look at the first coefficient in front of x, you have 8 and 3. They're not same opposites. 15 and 12 are not same opposites. So that means we're going to start with step 2. Now, which one are you going to eliminate? The coefficients in front of x or the coefficients in front of y? Well, it doesn't matter. You can pick whichever you want. But for this, I will pick 8 and 3. I'm going to get rid of the coefficients in front of x. Why? Because these numbers are smaller. It'll be easier to work with and they're smaller. Again, 8 and 3, 12, 15, none of these cancel out. So I'm going to get rid of x, and that's because 8 and 3 are smaller. Smaller numbers are easier to work with, so I'm going to eliminate these two coefficients by turning them both into 24s. Now, to make it 24, I would have to multiply this whole thing by 3. And I will also have to multiply this whole thing by 8. So 3 times 8 is 24. 8 times 3 is 24. However, I have to make them the opposite. So multiply one of them by negative, and I'm going to multiply the second one by negative. So then it will become opposites. And let's see what you get when you multiply. So we're going to distribute. Make sure you multiply everything by 3. So you would have 24x. 3 times 15 is 45 plus 45y equals 3 times 193, and that's going to be neg 579. Then the second equation, I'm going to multiply by negative 8. Negative 8 times 3 is negative 24, so I have negative 24x. Negative 8 times negative 12y will be negative 96y equals negative 8 times 117 will give me negative 936. So, can you see that 24 and negative 24, they're same opposites and they're going to cancel out? Good. So now we can move on to step 3, which is to add, to eliminate. So we're doing step 3 by adding 24 plus negative 24, x's cancel out. So 45 plus negative 96 will give us negative 51y equals 579 plus negative 936 will be negative 357. Divide both sides by negative 51. Then y will be, if you divide them, 7. Our y value we found is 7. So our solution so far, our y value is 7, so it'll be something comma 7. We only found half of our answer. So our next step is to substitute, remember, substitute x equals 7 to solve for y equals 7, to solve for x. But again, you're going to substitute into one of these equations. And you're going to pick whichever looks easier to you. And for this, I guess I'll go with the second one because this has 3, which is smaller. So I'm going to substitute into the second equation, 3x plus 12y equals 117, but again, we're substituting y equals 7, so that y should be 7. Then I would have 3x plus 12 times 7, which is 84, equals 117. Subtract both sides by 84. 3x is equal to 117 minus negative 84 will give me 33. Divide both sides by 3. X is equal to 11. So now I found the other half, that x is equal to 11. So we have our solution as ordered pair, and again, from previous, like we did, you always want to check. You want to make sure that this is the right answer by putting x equals 11 and y equals 7 into these equations. I'm going to skip that for now, but if you would like, you can definitely use that extra space in your notes to show me how you're checking your solution. So you have both equation, 8x plus 15y equals 193, and then you have the other equation, 3x plus 12y equals 117, and you want to make sure that you plug in 11 here and 7 here, 11 here, 7, and see if that makes the equations true. And like I said, I'm going to skip that for now, and I'm just going to write our solution. X is the cost of each hosta, and that means hosta is $11 each, or it costs $11 each, and daylily is y equals 7, so $7 each. And that will be our final answer because this is a word problem. We have to tell them what x11 is what y is. X is hosta and y is daylily. So that will be our final answer. Okay, so that's the end of our Unit 5 Lesson 3 video notes. Please make sure you double check, write down any questions you have. Any extra notes will be extra credit. Please remember to do your practice and you will be done with this lesson. Thank you.